Raj, welcome to the AI4India podcast. It's great to have you. To our viewers, a quick introduction of Mr. Raj Bhatt. Raj is the CEO of Knowledge Foundry Business Solutions, an AI and machine learning services firm based out of India and specifically Bangalore. Knowledge Foundry works with a range of clients, right from the hospitality sector to the insurance sector. And Raj is, I think, it was founded in 2008, and ever since its inception, Raj has been leading it. Prior to starting Knowledge Foundry, Raj has a range of experience in the management consulting industry, having worked at Booz Allen Hamilton and Adventus. And he also holds the degrees that are the envy of every Indian parent, the combination of a BTech from IIT Bombay and an MBA from IIM Ahmedabad. So great credentials, great work experience, and we're very excited to speak to you today. We have a very interesting conversation lined up for our audience. But before we get into that, Raj, I think it'd be great if we can learn a bit more about your journey, specifically in the artificial intelligence area, and about the work that Knowledge Foundry is doing.
Absolutely. First of all, thanks, Karam, for having me, and thanks for the glowing introduction. So, as you rightly mentioned, I came back from the US in 2005, started working for an analytics startup here in Bangalore. And when that startup got sold out, that's when we started Knowledge Foundry way back in 2008. And we worked on multiple waves of analytics and predictive analytics and data science to begin with, and then gradually came into the space of AI and machine learning. So for the past 7, 8 years, we've handled client cases in NLP, computer vision. We'll give you some examples in NLP for an online portal, a leading portal. What we did was created similarity metrics between millions of articles so that they could recommend the right set of articles to each member of their audience. And this is a hugely scaled solution. In computer vision, some of the problems that we've tackled are, analyzing images of objects to get the features of those objects. This is for an e-commerce kind of client, where we just have the image of the product and we can analyze the image to say what is the texture of the product, what is the exact color of the product, and so on and so forth. Whether it has buttons or not, does it have a collar? All these are important things when images are coming out of studios for the e-commerce company. Some other examples include, size estimation for a fitment, mobile fitment app. So users take images and then the solution will give you the exact fit for that particular individual. Or, object detection, which can be used in use cases like self-checkout for a bakery. You just place your tray in front of the checkout camera and automatically it will check out. So those are things we've done over the last 7, 8 years. Then we moved on to things like using neural networks for forecasting, large-scale forecasting applications, like working for a European MVNO. We forecast the usage of each of their millions of users so that they can optimize their cost with their wholesale provider. And then, around 3 years ago, we got into generative AI. Firstly, to replace some of our NLP algorithms, because people were talking about GPTs and how they will eventually replace BERT or will do some of the work that BERT is doing. But then specific applications on content generation, like e-commerce product descriptions based on features. How can we have different descriptions for different segments of the audience and personalize the product description is something we started doing 2.5, 3 years ago. For the pharma industry, we helped some of our clients draft the clinical study reports, which are used for filings with the FDA, for example. And then a couple of years, newer and newer concepts in generative AI have come through. So we are doing multimodal chatbots. We've done a whole bunch of voice agents as that became popular around a year ago. We've done customer service support agents, which can look up tools and interact with agents. And then in the India space, Indic call center analytics is something we've done using generative AI. And we've also started offering some of our red teaming services for enterprise agents, because we feel that that's a space that is underserved. So this is a broad set of things that we do, ranging from computer vision to generative AI.
Fascinating. Thank you for explaining that, Raj. I think these are the kind of applications of AI that I think most enterprises really need today to kind of stay ahead of the curve. But I think I want to go back to one or two things that you mentioned, specifically about how you've been helping clients with agents, for example, which is a great segue into what we want to talk about today, which is agentic AI. Now, for those of us who are uninitiated, could you help us define what an agentic AI is and how it differs from the AI formats or AI forms that we're used to, which are LLMs, like ChatGPT or Gemini. So, what is the difference for someone who hasn't used a agentic AI or an AI agent?
So the key difference between a single turn Q&A chatbot or an LLM versus an agent is that the agent can reason for itself. It can reflect on some of the answers and can autonomously take decisions or autonomously do tasks with a little bit of input from human beings at the end, right? So as Andrew Ng put said, there are four basic differences between LLMs and agents. One is the act of planning a task. Secondly, the act of reflecting on what is the output that you are generating. So, and agents, the advantage, of course, is that in traditional LLMs, you'll have a lot of hallucination. Whereas by having reflection, some of these agents are able to overcome some of the classical hallucinational problems, because they'll say, okay, am I doing this right? Let me just check my answer and then go back, right? So that's the second difference. The third difference is tool calling. Can it call Google Calendar? Can it call Google Maps? Can it call, Open Table to make a restaurant reservation? Can it call a ticket booking service? Can it call a weather service? All of these things are what is called function calling or tool calling, and that's an important aspect of agents. Also, they are multi-agent collaborators. So an agent might be composed of small sub-agents. Like, for example, something that plans the task, a planning agent, then an execution agent, a reflection agent, and then finally something that produces the action or the actual decision. So all of these features make it very different from a single shot Q&A chatbot or an LLM. But having said that, some of the recent LLM models are more and more agentic in nature, or they can support agentic thought. Like, for example, you look at O3 or Gemini 2.5 Pro or Claude 4, they have reasoning, they have tool calling. So, using their APIs, one can easily build agents. So, they are slowly getting to the step where they themselves, there are services like Operator, for example, which is a fully fledged agent, or Claude Code has aspects of it which are agentic in nature. So you'll see LLMs continue to become more like agents in the future.
Interesting. So the lines are getting blurred slowly.
Correct, correct. That is correct.
Yeah. I think we've spoken once before, and in that conversation, you mentioned something very interesting when we talk about AI agents. I remember you telling me that a lot of the products or agents on the market today aren't actually very agentic in nature, but they're more akin to workflow tools,
Yes.
and a lot of people may not realize that. So could you maybe elaborate on on the issue, and also explain, or give examples rather of what actual agentic AIs or artificial intelligence agents are out there that people can look to?
Correct. That's a good question. See, there are many voice agents which are being launched in the US market, and truly many of these voice agents are not agentic enough. And agenticness is kind of a concept that is becoming very popular now, because everyone seems to be, getting into the snake oil business. So one has to be careful what one's calling an agent. Uh, you know, in voice agents, for example, there are many applications which are very latency sensitive. You cannot have high latency more than a few hundred milliseconds. And therefore, what we call an agent truly is not reflecting or not calling too many tools. To give you an example, a simple outbound sales agent, which is looking at some PDFs, understanding the product, doing a rag on it, and executing phone calls saying, hey, do you want this product? Here are the features, here's the price, and can chat about it and can hand off to a human agent. That is a workflow. That is not agentic. It is not taking a decision. It is not really reflecting on itself, because when you add a reflecting or a reasoning loop, it adds several hundred milliseconds of delay, which you cannot afford in this application. The other example for I would say, is when you have a technical support agent for product technical support. Suppose you're calling a refrigerator company or a printer company, and the agent has a big product manual at the back end, and all it's doing is it's using RAG to answer your questions, or if it cannot answer, it'll hand you off to a human agent. Again, this is a workflow based application. It is not so much an agentic application per se. On the other hand, in voice agents, there are agentic applications as well. For example, I talked about customer service agents. If these customer service agents are hooked up with databases and ticketing systems like a classic Jira or a Zendesk, then suddenly they are agentic in nature, because they are taking your request. They can edit or modify or add or delete trouble tickets or resolve trouble tickets. Then it is truly agentic. Or you're looking at a appointment setting agent which has access to a doctor's calendar, and it can proactively suggest time slots when the doctor is available and the customer might want to come in. That's an agentic voice agent. So those are examples of some of the voice agents which are truly agentic in nature.
Wonderful. I think that clarifies a lot of things for all of us. I want to bring your attention next to a survey that I came across. It's a quarterly survey that KPMG does, specifically focused on the US market. And in that, they found that 65% of top US companies that they surveyed are currently piloting AI agents, which is up from last quarter, where it was about 37%. But what was interesting was, despite this high interest and the number of pilots happening, deployment hasn't gone up at the same rate. So only 11% are actually deploying them, and this isn't different from last quarter. So why do you think there's a gap between pilots and ultimately deploying these tools? And given their significance and the kind of things that they can do, it seems strange that not more companies are actually utilizing them now. So in your experience, why do you feel that is? And what can be done to kind of bridge this gap?
Sure, sure. So usually there will be a lag between companies piloting a particular new technology and then those companies putting them into production. In this particular case, as indeed with the earlier Gen AI use cases, the gap seems to be quite significant. As you rightly pointed out, according to KPMG, 65% of companies in the US are piloting agents, but only 11% have anything in production. And eventually, some of these companies will go into production, but then there are a couple of really serious hurdles that they need to overcome. The first and most important hurdle is that of security and evaluation, right? See, agents are taking some pretty significant decisions on behalf of users. For example, customer service agents can modify tickets inside your ticketing system, or an agent that is allowed to book a flight ticket or a hotel, can go ahead and book something that you may not like eventually, or may cost much more than you want. But of course, there will be human in the loop in some of these cases where they ask the user saying, hey, can I do this or not? But are we comfortable letting agents do what they want to do and come up with some suggestions which are absolutely ridiculously absurd, right? I don't think many of these companies are comfortable with that yet. So there is a matter of security because some of these agents, if they're allowed to access customer databases, then how can people break into those agents and get information is something they need to think about. And evals have not really fully evolved for agents. It's still a work in progress. Remember that agents are fundamentally different from simple LLMs in that their output is decisions or actions that they are taking. So the eval framework need to evaluate the actions and the decisions they're taking, not just the output that a simple LLM part of it is taking. And the current evals are primarily oriented towards LLMs, not towards agents. So until that evolves, there will be hurdles to companies putting these things into production. They will have to evolve their own evals. They will have to do human red teaming to make sure that nothing breaks before they launch it, right? And the second most important hurdle is really cost, and that is particularly important in countries like India because we are a very cost sensitive country. Our GDP per capita and our cost expectations are much lower than the Western markets, right? So to give you an example, Salesforce has a lot of offtake for its agent force agents, which cost around $2 per chat interaction. And it touts on its website that, hey, with $2 per interaction, assuming a chat support agent, human agent can support, say, around 20,000 interactions in a year, Salesforce would cost you $40,000. And that would be a real cost saving if your support agent is based in the Western countries like the US or UK or Western Europe, because your cost for a qualified support agent there could be higher than $60,000 all told. But if the support process is already migrated to Asia, if it's been done in India or Philippines, then your cost for doing it is much lesser. And therefore, it's a barrier because if I'm doing it with human beings at $20,000, $25,000, $30,000, why would I pay Salesforce $40,000 to deploy Agentforce? So that's another big hurdle, I think. Both of these hurdles, security, evals, and cost, will eventually be overcome. The cost will go down. You recently must have heard that OpenAI has reduced the cost for O3 by 80%. And so there will be a wave of agents coming through because cost has reduced. But again, security and evals need to be bolstered before companies can do that.
Makes sense. And I think, like you said, I think costs will eventually come down. And I think, there's no avoiding the future, so to speak. So I think eventually
So, yeah.
we will see more and more agents, especially as you mentioned, we have LLMs that are becoming more agentic in their nature. So I think, it's perhaps inevitable. But since you mentioned the Indian context, I thought I'd also ask you one thing that, we are very focused on at AI for India is procuring and ensuring that localized data is kind of utilized to train AI models or AI applications for specific Indian context.
Yes.
So, how important do you think a campaign like that is, and how important do you think local data is when it comes to creating AI agents for India?
Yeah, it is absolutely very important. I've been involved with AI for India for the past more than a year now. And Data Dan is an initiative that got started to encourage corporates, individuals, government institutions to donate their data to development of local AI models and local databases so that firstly the local ecosystem develops as well as they get benefit from these AI models, right? So I'll give you a couple of examples where this is important, right? Number one is in local models for local languages. India has so many Indic languages. Only 11% of India really can talk and understand English. The remaining 89% talks a local language, depending on the state and even depending on the district that they live in. There are so many dialects and accents, right? So we need to create databases which capture these dialects and accents so that local language models can be built, which will eventually fuel applications like voice agents for Bhojpuri, for Tamil, for Malayalam, for Assamese, for Punjabi. Eventually, we will have voice agents if we have these databases which allow us to test these models, right? And of course, there are some companies already which are doing good work in launching local models. The more data we have, the better it is for these companies to build better and better models, right? And secondly, I'll give you another example, which is autonomous driving, drone delivery. These are not the classic Gen AI models, but these are AI applications. And in the West, autonomous driving is already there. You can board a car in San Francisco, which can take you from point A to point B without a driver. But in India, imagine us trying to do that. But the main problem is we do not have data sets of local videos showing traffic conditions, LiDAR videos. We don't have, for drones, we do not have videos of rooftops suggesting where can the drone land. So all of these data sets, if they can be built up, and I can talk of many other data sets, localized traffic data set, localized events data sets telling you what are the events in a particular locality and in a particular city. Can that be used to help businesses and NGOs to plan their schedules better? All of these will help not just bring efficiencies in the Indian market, but also help create cutting edge AI applications, which are required by the local population. And the base of the pyramid will benefit by having these models and applications, because we'll be able to deliver them cheaper when there is a uh, available open source local database, and we don't have to rely on foreign companies and pay money to access databases that they've built of local data.
Absolutely. I think I couldn't have put it better myself. So thank you so much for really explaining to everyone, the importance of a campaign like Data Dam. We've covered a lot of ground here today, so I have to really thank you for taking the time out from, your very busy schedule. And it's been a great conversation. I hope our audience takes away some very valuable learnings from it. So thank you very much, and I hope to speak to you again soon. And maybe we'll be in a different phase of the evolution of AI agents by then.
Thanks a lot, Karam, and pleasure talking to you.
Yeah, likewise. Thank you.